what is oxidation half reaction, what is reduction half reaction. At first we have to clear it. Let's see. Redox reaction means to say oxidation half reaction plus reduction half reaction. And as we know that oil and grain, oxidation is loss of electron and reduction is gain of electron. Okay. So now we are considering one equation, one full reaction, that is Zn solid plus CO2 plus aquated, because it gets ionized in the aqueous solution. So we get Zn2 plus aquated plus copper solid. So here we can see Zn is converted to Zn2 plus. That means it loses electrons, and loss of electrons is oxidation. So it is oxidation half reaction. And now in that case, in case of Cu2 plus, it takes 2 electrons and converted to Cu solid. So reduction is gain of electron. Here it is the reduction half reaction. So now we can get the net reaction by cancelling these two. So this is our revision lesson. Revision lesson, we get from the revision lessons that oxidation is a loss of electron and reduction is gain of electron. Now we will study what is oxidation number.
Yes, there are some rules for the oxidation number. First of all, oxidation number is 0 in the free state. For example, O2 0, sodium 0, chlorine 0, hydrogen in free state 0. Next is polyatomic ion. The sum of the oxidation numbers of all the atoms present in it is equal to the charge of the ions. NH4 plus. NH4 plus means the oxidation number plus 1. Like sulfate, except for 2 minus, oxidation number is minus 2. These are the polyatomic ions. And the oxidation numbers of this kind of polyatomic ions is equal to the charge of these ions. Oxidation numbers of ion is equal to its charge. Like Na plus, its oxidation number is plus 1. Ca2 plus, plus 2. O2 minus, minus 2, etc. The algebraic sum of the oxidation numbers of the neutral molecule is always 0. Neutral molecules, in case of the neutral molecules, the sum of the oxidation numbers is always equal to 0, which we will prove by giving an example. Okay. Next, oxidation number of hydrogen is plus 1. But these oxidation numbers of this hydrogen in hydrides like CaH2, calcium hydrides, LiH, lithium hydrides, here in that cases, the oxidation numbers of hydrogen is minus 1. Why? Because the sum of the oxidation numbers of a neutral molecule is 0. So here lithium is plus 1. If we want to make it 0, then it has to be minus 1. Plus 1 minus 1 equals to 0, which is given in point number 4. So next is oxidation numbers of oxygen is minus 2. But in case of the peroxide bond, the oxidation numbers of oxygen is minus 1. What is peroxide bond? This is peroxide bond. We will see an example for this kind of peroxide bond. Okay. Now we are taking this example. Find the oxidation numbers of KClO4. Oxidation numbers of chlorine in KClO4. So we know that the total oxidation numbers of the neutral molecule is 0. We don't know chlorine oxidation numbers of chlorine, but we know the oxidation numbers of oxygen and we know the oxidation numbers of potassium. So it is plus 1, it is minus 2, but the numbers of atoms of oxygen is 4. So minus 2 into 4. Next, we are taking another example. Find the oxidation numbers of sulfur in sulfuric acid. plus 2 plus x minus 2, 4, 0. So, this is the oxidation number of sulfur in sulfuric acid. Now we will see some exceptional cases. You have to find the oxidation numbers of chromium in case of CrO5. At first, you can see here O5. So mistakenly you can write that is x plus minus 2 into 5 equals to 0. So here x equals to plus 10. But it is wrong. The oxidation number here will depend on the structure of CrO5. So let's see what is the actual structure of the CrO5. Cr, double bond O, 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 O. Okay. This is the structure of CrO5. And you can see here is 1, 2, 3, 4. 4 peroxo bonds and 1 is oxygen. So, just remember the rules. Let's see X. For the 4 peroxide bond, peroxo oxygen, that is minus 1 into 4 plus minus 2 equals to 0. So x minus 4 minus 2, 0. X plus 6. So the oxidation numbers of chromium is actually plus 6. At first we have to study the structure of the H2SO5. As we said earlier, that is here is also the peroxo bond. So we have to judge first how many numbers of peroxo bonds are existing here. So let's see what is the structure of H2SO5. H2S 1, 2, 3, 4, 5. This is the structure of H2SO5. As you can see, this is the peroxo bond, and 3 oxygen atoms is attached with this kind of peroxo bond. So you have to find the oxidation numbers of sulfur. So assume it is X. Here 2 hydrogen exists, so plus 1 into 2. 2 peroxo oxygen. So you can say, and 3 normal oxygen equal to 0. And here it is 1 for sulfur plus X. So plus 2 minus 2 minus 6 plus 6 equals to 0. So the oxidation number of sulfur is plus 6. Next we will see Na2H2O3. Here we also will study the structure of it. Here you can see you have to find the oxidation numbers of sulfur of this sulfur. But here this sulfur is associated with the first sulfur with the coordinate bond. Coordinate bond is the unstable bond. Why? Because it draws electrons of this bond to itself. Here you can see 2 sodium atoms, 3 oxygen atoms, and sulfur atom held by the coordinate bond. Here this sulfur atom held by the coordinate bond, this oxidation number is minus 2. For sodium, plus 1 for 2 atoms, 3 oxygen. This sulfur we don't know, and minus 2 for the coordinated sulfur, coordinated bond with sulfur. So here the oxidation number of this sulfur is plus 6. Here and here, the oxidation number of this kind of sulfur is plus 6. Now we will see the balancing in terms of the oxidation number. We study balancing chemical equations by the oxidation number. So let's see. H2S plus Al2 plus H2HCl plus H2SO4. Here you can see the oxidation number of chlorine is 0. But here in that case, minus 1. Why? This one is hydrogen, so the chlorine has to be minus 1 for making it 0, for nullifying the whole ions. So here the change in oxidation number 0, minus of minus 1 change, so it is plus 1, but it is considered for one chlorine atom, but here is two chlorine atom. Okay, now we will study for sulfur. Now we are considering sulfur. It is plus 2, so here is minus 2, and here the sulfur is minus 2 plus 2, that is change in oxidation number for sulfur. Plus 6 minus of minus 2 equals to 8 plus 8. So, to neutralize the effect of increase and decrease of the oxidation number in the given equation, the number of the molecules of H2S and chlorine should be in the ratio. So, the number of molecules of H2S and chlorine should be in the ratio of 2:8, that is equals to 1:4 before H2S. We are putting 4. Next, equal to sign. Okay. Next you get, likewise we are writing HCl plus H2SO4. How many chlorine atoms are there? 4 into 2, 8. 8. Okay. 8 HCl, oxygen, H2O. Here it is H2SO4. Everything is not balanced here. You have to balance the oxygen first. 4. 4 2s are 8. 8. Right? Here 2. So 8 plus 2, 10. Sulfur 1, sulfur 1. Chlorine 4 2s are 8. Here is 8. Oxygen 4 1s are 4. Here it is 4. So now it is balanced. After deriving the ratio, you have to balance the whole equation by calculating this in the last line of the chemical equation. Now it is fully balanced. If you can't balance this equation at the last line, then don't give the equal to sign. After putting this ratio here, you can give this sign, arrow sign. But if you give the equals to sign, you have to balance it at any cost. Otherwise, you will score 0 out of 2. Or if you can't balance this, and if you give this sign, arrow sign, then you can easily score 1 out of 2. So it is better to score 1 out of 2 instead of 0. CO plus NH3, CO plus N2 plus H2. Here you can see nitrogen in free state, that is 0. Here it is plus 3, the nitrogen is minus 3. Here the copper is in free state, 0. So it is minus 2, so here the copper is plus 2. So you can now calculate the change in oxidation numbers of nitrogen. Okay? So the ratio will be 3:2. But 1 minute. 3 for nitrogen and 2 for copper, 2 NH3. So the 2 places before NH3 and 3 before. Here we are placing 3 before, the ratio becomes 3:2. So we get the 3:2, 3 before the CuO and 2 before the NH3. Likewise, we get Cu plus N2 plus H2O. Now you can balance it easily. 3CO, that means 3Cu, N2, here it is balanced, and 2 NH3. So here you get 3H2O. Now everything is fine. This is all about the oxidation number video. In our next video, we will discuss the balancing by the ionic method, ionic balancing. Okay.